I see a nice simple quadratic equation with a coefficient of 1 in front of the x squared. So I'm going to see if I can factor this. I need two things that multiply to 24 and add to negative 14. I know 24 is 12 times 2. 12 plus 2 is 14. And negative 12 times negative 2 also gives me a positive 24. So I know those are my two numbers that I can use to factor this. If I couldn't factor it, I would just use the quadratic algorithm on it. But since I can factor it, it becomes x minus 12 times x minus 2 equals 0. So either x minus 12 is 0 or x minus 2 is 0. And you just solve both of those equations. So x equals 12 and x equals 2 are two different solutions for this problem. The next one is a linear equation. The highest power of x is 1. The fractions make it look maybe a little complicated or a little intimidating. So remember, if I want to get rid of all the fractions at once, I can just multiply by the least common denominator. So I'm going to write my three denominators here in their prime factor decomposition. So break it up into the smallest pieces possible. And then the least common denominator I can get by taking the largest power of each of those prime numbers and multiplying them together. So I get 2 squared times 3 to the first power. That's 4 times 3. It's 12. So if I multiply both sides of the equation by 12, it will knock out all the denominators at once. That'll be kind of nice. I know 12 over 3 is 4. So for that first term, I get 4 times 2. 12 over 4 is 3, so I get 3 times 7x. 12 over 6 is 2, so I get 2 times 5x. Then 12 times 1 is 12. Simplify that, combine like terms, move the constants to one side, the variables to the other side. And then I can just divide by 11 to finish it up. And then this last one is another exponential equation where we're solving for the base. So I can quickly just take the 7th root of both sides or raise it to the 1/7 power. I don't need a plus or minus because the exponent is odd.